lots of math skills. So, kapit lang. Okay. Okay, so our session for today is about chapter 5 sa laboratory component, which is on the monoprotic and the polyprotic acid-base titration. Okay, so when you say monoprotic, we are referring to molecules that react with one protons, isang H. When you say polyprotic, we are referring to molecules that react with more than one hydronium ion. Okay, so yan. So, yan yung di-discuss natin. This is the chapter outline. So, for this session, we will try to cover the following topics. So, titration overview. I believe kung nag-lesson si lecture sa inyo last week, na-discuss na to. Pero kung hindi siya nag-lecture, okay lang. Kasi ako rin, hindi ako nag-lecture last week na to give way for your extended break. Okay? So yan, so we will go with titration overview. More of this will be discussed in the lecture, followed by some of the concepts or calculations that are necessary. No? Re-review lang tayo ng mga kailangan nating concept dito. And then we will proceed with the monoprotic titration. Okay. So there are 3 subcategories: strong acid, strong base, weak acid, strong base, and weak base, strong acid. Okay. So lahat ng to, madidiscuss natin to in depth. Then for the consecutive meetings, we will discuss acid-base titration indicators. Ito ay di-discuss din sa lecture. So, dadaanan pa rin natin. Polyprotic acid-base titration and titration of acid-base mixture. Okay. So, this chapter is a very long chapter and a very math-intensive chapter. So, please bear with me, no? Kasi ang dami nating gagawin talaga. And yun na yung kaya ko gawin. No? Yung simplified version, nagawa ko na dito. So, all you have to do is to follow the steps na lang. Okay? So, yun. So, let's have an overview of titration. So, if you watch the YouTube video I sent you last time, yun sa playlist ko dati, last year din yun eh, pandemic din yun, kaya gumawa ko ng YouTube videos ko na yun. Doon ako nag-start maggawa ng lessons. So, yan. So, if you watch the video, I told you there that titration is a form or is a type of a volumetric analysis. Okay. So, when you say volumetric analysis, we refer to types of analysis that makes use of liquids, di ba? So, yun yung volumetric analysis. May liquid na ginagamit. Kaya nga volumetric. Okay. So this is a volumetric analysis in which you react your substance to completion, and the completion of that process is often observed using chemical indicators. Okay? So basically, ganito lang yung idea. You have a liquid here which contains some molecules that will react to the molecules present in the liquid here sa baba. So kapag yung dalawang yan, nag-react sila completely, there will be a corresponding color change with the help of chemical indicators. Okay? So, ito yung nakikita nyo sa YouTube, or kung nagawa nyo na to sa laboratory during your high school, yun yung biglang nagpipink yung kulay ng solution. Yung process na yun ay titration process. Okay? Okay, so basically, titration is a volumetric analysis which makes use of the two liquids reacting to one another to completion. And once the reaction is complete, may corresponding color change with the help of chemical indicators. Okay? So in our discussion sa chapter na to, marami kasing forms of titration. There's a neutralization titration, there is a redox titration, there is complexometric titration, there is EDTA titration, so on and so forth. Pag BS Chem kayo, madidiscuss yan lahat. However, medtech tayo, so we are focused sa basics lang. Okay, so the basic form of titration is the neutralization titration. Okay, so from the word itself, neutralization, it means that we are neutralizing species, no? When you say neutralizing species, ibig sabihin nun, may acid and may base ka. Pag pinagsama mo sila, maging neutral product sila, di ba? Okay, so that means neutralization titration includes the use of acids and bases. Okay, so when we add certain amounts of acids and base, magko-complete yung reaction. Okay, so saan ginagamit itong titration? For example, nag-work kayo sa chemical laboratory, kunwari may powdered soap, detergent. Gusto mo alamin kung ano components ng detergent. You can determine the components of detergent using titration. Okay. Malalaman mo kung ano yung mga chemical species na nandun gamit ang titration. For example, sa liquid din, 'di ba? Kunwari tap water. Paano mo malalaman kung heavy water 'yon or safe inumin? Titration naman 'yon. Okay? So ganun. So kunwari, gusto mo alamin gaano karaming protein meron sa isang food product. So pwede ka gumamit ng neutralization titration in the process called Kjeldal method, no? So di na natin discuss 'yon in depth kasi pang BS Chem na siya. Although makikita niyo 'yan sa textbook niyo. Okay? So yan. So as you can see, there are lots of forms of titration. However, we are focused on the neutralization concept only. The reaction of acids and bases to produce salt. Na. So this is the typical titration setup. Ito na lang. So this is the typical titration setup. You have the Erlenmeyer flask, which contains your unknown species called the analytes. So dito yung analytes, nandito yung mga substance na i-analyze mo. For example, yung tubig sa poso, o kaya yung liquid detergent, gusto mo malaman components noon, lagay mo dyan. Okay? And iba pang mga bagay. Okay? So basically, lahat ng gusto mo i-analyze nandito sa Erlenmeyer flask. So ito yung itsura ng Erlenmeyer flask. No? So maliit yung neck niya, then papalaki siya papunta sa bottom. Okay, so bakit ganyan yung shape niyan? Kasi ini-swirl namin yan. So ini-swirl yan. Okay, di ba parang wine glass, ini-swirl natin. So ganun din dito. So we swirl this so that the chemicals will be distributed evenly. So on the top part, we have the burette. Okay, so you already know the burette. This is a very long tube that holds liquids, no, that are used in titration. So kung nandito yung analyte, dito sa burette nilalagay yung titrant. Okay? So a titrant is a substance with known concentration. So bali gagawin mo, you react substance with known concentration with the unknown. And using stoichiometry, pwede mo malaman kung ano yung unknown. Okay? So ganun lang. Etong burette natin, nakaklamp yan sa iron stand using an iron clamp. Okay? And we use wash bottles and other beakers and indicators, no, para ma-complete yung setup. And we will know if our reaction is complete when ang color ng solution natin ay magiging faint pink. Okay? So magiging faint pink yung color ng solution natin. Okay. So kung tayo ay nasa laboratory setup ngayon, titration reaction is a very good ang titration reaction, this is a very kalimutan ko yung term. Maganda to gawin sa laboratory kasi mapapansin niyo talaga when you do the reaction, magbabago yung color ng substance sa container mo. Okay. If ikaw fan ka ng mga colors, mag-enjoy ka sa titration. Okay? So yan yung titration process natin. Okay, so again, this is the titration setup. In the Erlenmeyer flask, you have your analytes, the substance na unknown. And in your burette, you have your titrant, substance with known quantity, known concentration. So pag pinag-react mo sila, depending on the volume used, pwede mo malaman kung ano yung concentrations ng analyte. Okay? Using stoichiometry. Okay? So these are some of the terms that we will encounter. So if you watch the YouTube video I sent you last time, yung recording ko last year, familiar na kayo with all this stuff. No? Pero again, daanan uli natin. When you say analyte, chapter 1 to, When you say analyte, these are substances with unknown concentration. Without known concentration, ibig sabihin hindi natin alam kung gaano sila karami. Paano mo malalaman kung gaano sila karami? You use titrant or standard. So titrants or standard are substances with known concentration. Depende sa dami netong nagamit, malalaman mo kung gaano to karami using stoich. Okay? So mamaya makikita niyo kung paano 'yan. Next one, we have indicators. So when you say indicators, we are referring to molecules, no, that produces color at different pH values. Okay? So yung pinakita ko kanina, this is the phenolphthalein indicator. So this is an organic molecule which turns purple kapag nasa basic solution. Okay? So that means kapag ang iyong reaction ay complete, magiging pink yan. Okay? So magta-transition siya to pink. Kasi kapag wala tayong indicator, di mo mapapansin kung tapos na yung reaction. So you have to add those molecules para mag-color. No? Once na nag-flash yung pink color, ibig sabihin nun, tapos na, stop na. Okay? So tawag natin sa kanila ay indicators. Those are molecules that changes color upon the completion of the reaction. Next one, we have the equivalence point. No? When you say equivalence point in titration, we refer to the volume, okay, at which your analyte and your titrant are stoichiometrically equivalent. Kaya nga equivalence point. Ibig sabihin nun, the moles of your analyte is equal to the moles of your titrant. That means the reaction is complete. Okay? Yun yung equivalence point. Again, that can be computed by stoichiometry. When you say endpoint naman, this is an estimate of the equivalence point. Okay? So, kumbaga, yung equivalence point, this is the exact volume of titrant that will neutralize all the species present, di ba? Parang ito yung parang ito yung stoichiometric value talaga na tapos na yung reaction pag na-reach mo tong volume na to. Equivalence point yon. However, endpoint yung na-observe natin sa laboratory. Okay. Ano yung endpoint? Sabi natin, endpoint is an estimate position of equivalence point. Kasi at endpoint, we will see color changes. Okay. So, ibig sabihin, itong faint pink color na to, this is rough approximation of the equivalence point. Okay. So, pag nag-pink yan, endpoint yon, yung equivalence point, malapit doon. Okay. So, parang ganun lang yung idea niyan. Okay. So, kung ano yung volume na nagamit doon, yun yung equivalence point. Itong na-observe mong color, tawag dyan endpoint. Okay. So, yun. Some people interchange endpoint and equivalence point. Although there is a subtle difference. When you say endpoint, approximate lang yun ng equivalence point. Although they are similar. No? Okay. So, yun lang yung mga jargons. Na-discuss na yan dun sa video kung napanood nyo. Okay. So, be familiar with them kasi magagamit natin sila later on. Okay? So, now, tingin lang muna tayo ng isang short video clip kasi wala tayo sa laboratory. So, sayang. Let's take a look kung paano gumagana yung titration. Okay? So, yan. Wait lang. Set up ko lang yung video. YouTube muna tayo, ha? Okay. So this is a video that will inform us kung paano mag-set up and how to perform titration. And then later on, i-summarize ko tong mga nangyayari dito sa video, ha? Sige.
Hi, I'm Jared Hyman, an assistant professor of chemistry at Elon University. Today, we will be discussing the proper titration technique using the complete single Burette assembly kit available from Carolina Biological Supply Company. This is the first in a two-part video series on titration. The purpose of a titration is to quantitatively determine the concentration of an unknown solution, commonly called the titrand or analyte, by adding a volume of a chemical with a known concentration called the titrant. To mark the endpoint of a titration, an indicator is added to the analyte. Let's review some of the equipment that's needed for a titration. Carolina's complete Burette assembly contains the basic equipment to get you started, including a Burette, ring stand, and a Burette clamp. A Burette is a long, narrow, graduated tube used to add titrant. It has a stopcock to regulate the flow of liquid. Notice that the markings on the Burette go from lowest at the top to highest at the bottom. The ring stand and Burette clamp are used to mount and secure your Burette. Other materials you will also need include a small funnel to help you fill the Burette, a 125 milliliter Erlenmeyer flask, which works best for titrations. The shape of the flask allows for more vigorous swirling than a beaker or other glassware and minimizes spill hazards. A volumetric pipette and pipette bulb to transfer a known volume of analyte to the flask. A wash bottle filled with deionized water, a beaker or flask of titrant and of analyte, indicator selected for your reaction, a reading card to help read the meniscus, and a sheet of white paper to help visualize the endpoint. To prepare your Burette for the titration, it is good laboratory practice to rinse your Burette thoroughly with deionized water, then with a small amount of titrant. After each rinse, open the stopcock to allow the liquid to drain out the bottom. If there is a lot of liquid clinging to the walls of the Burette, then thoroughly clean your Burette and repeat the rinse process. The accuracy of this technique is dependent on the titrant flowing into the flask and not sticking to the walls of the Burette. Mount the Burette in the clamp, making sure it is positioned vertically, and there is enough room to position your flask underneath the tip. Check to see that the stopcock is in the closed position. Insert the funnel into the top of the Burette and fill with titrant almost to the top. Filling exactly to the 0 mark is not necessary, but you do need sufficient titrant to complete the reaction. Check the column for air bubbles and gently tap to free them from the side walls. Remove the funnel. Place the Erlenmeyer flask under the tip and open the stopcock to allow a few milliliters of titrant to flow through, releasing any trapped air. Rinse the tip of the Burette with water. Empty the liquid into a waste container and thoroughly rinse the flask. It is not necessary to dry the flask. Record your starting volume. It is important to accurately read the volume on the Burette. First, note that the liquid forms a concave meniscus because the water pulls itself up the side walls of the glass. You should read the volume from the bottom of the meniscus at eye level. Secondly, it is important to read your volume to the correct number of significant figures. This Burette indicates volume to the nearest 0.1 milliliters. With any graduated glassware, record the volume to one additional decimal place beyond the smallest graduation. In this case, record the volume to the nearest hundredth of a milliliter, estimating the final place. Use the volumetric pipette to transfer the analyte to the flask. Add a few drops of indicator to the flask and swirl. Place the flask under the tip of the Burette. Record this volume. Placing a piece of white paper under the Erlenmeyer flask may make it easier to detect the color change. Operating the Burette requires 2 hands. One hand turns the stopcock, while the other hand swirls the flask. Practice turning the stopcock a few times to familiarize yourself with how quickly the flow starts and stops. It is common laboratory practice that the first titration is an estimate. Open up the stopcock and allow the titrant to enter the flask quickly. Continuously swirl the flask. As the volume of titrant in the flask increases, the color of the indicator appears, then disappears as you swirl. When the analyte becomes a colored solution, close the stopcock. Record the final volume of the Burette. Subtract the initial volume from this final volume to get the estimated volume of titrant needed for this titration. Knowing the volume that is a little past the endpoint, subtract 5 milliliters from that number to get the amount of titrant that can be safely added before a slower addition is required. As the estimate titration shows, a dark-colored solution indicates an excess of titrant has been added. The desired endpoint is a pale, faintly colored analyte. To reduce the risk of passing the endpoint, slow down the addition of titrant when flashes of color begin to appear in the analyte. Adjust the stopcock to slow the flow of titrant to a drop-wise rate. Continue to swirl the flask with one hand and keep the other hand ready to close the stopcock. When you notice the indicator taking longer to fade, close the stopcock. Rinse the tip of the burette with deionized water and swirl the flask. Record the final volume on the burette. If the analyte remains faintly colored, then you have reached the endpoint. If the analyte is still colorless, then repeat these steps. Add a drop, rinse, swirl, and record until a faint color persists. Typically, titrations are performed in triplicate. Use the average volume of the titrant required to reach the endpoint for any calculations. You now know how to properly perform a titration. Be sure to check out the second video in this series. In that video, we will go over the proper procedure for determining the concentration of an unknown acid solution using a...
Okay, so anyway, so tapos na siya magsalita. Tinabas eh. Okay, so basically what you just watch is the typical flow of the titration process. Okay? So, yan nga, sabi ko sa inyo earlier that in performing titration experiments, you should have a burette which will hold the titrant, and you have an Erlenmeyer flask which holds your analyte. Okay? So, dun sa analyte mo, okay, so ito yon. So, dito sa analyte mo, you will add a few drops of indicator so that there will be a color change upon the completion of the reaction. No? Okay? Pag na-reach na niya yung equivalence point or end point, doon na siya magkakaroon ng color change. Okay? So, mapapansin nyo dito sa part ng video na to, when the titrant is added, nagiging pink, di ba? Pero ini-swirl niya, tapos nawawala yung kulay pink. Kaya nga nakaka-enjoy itong titration experiment pag nasa face-to-face class tayo, no? Kasi makikita mo yung pink bigla-bigla nawawala. Okay? Bakit? Kasi the pink color is because yung ating indicator nagre-react siya with the base, no? Yung sabihin, at that portion of the liquid, tapos na yung reaction. However, sa other parts ng solution, hindi. So the reason why we have to swirl is to evenly distribute the molecules, no? Pag evenly distributed yung molecules, tas hindi pa pala kompleto yung moles ng titrant na kailangan maidagdag, mag-disappear yung color. And pag in-swirl mo yan, tas kulang pa yung moles ng titrant na inad mo, mawawala yung pink color. Kailan magiging constant yung pink color? Kapag na-reach mo na yung equivalence point. Okay? So, marireach mo yung pink color once equivalence point na yan. Mapapansin nyo sa unang video, sabi niya, gawin mo daw munang heavy pink, no? Ano yung purpose? Bakit ginawa niyang ganito? Ang purpose is para ma-estimate niya saan siya magdadahan-dahan. Okay? Kaya sabi niya mag-minus 5 ml daw kapag naging super dark color. Kasi makikita niyo dun sa titration, mabilis minsan yung pagbaba ng liquid eh. Mabilis yung pag-drop ng liquid. So, kunwari, na-reach mo na yung minus 5 ml bago ma-achieve tong color na to. Doon ka na mag-drop wise. Okay? So, kailangan kasi ang ma-achieve mong color is this faint pink color lang. Pag na-reach mo to, mali na. No? Mali na yung ginawa mo. Ulit ka ulit. Okay? So, again, ang purpose lang ba't niya in-overshoot is para ma-estimate niya saan siya magdadahan-dahan. Okay? And then once na magdahan-dahan ka na, you should observe this faint pink color. Pag nakita mo na yan, that means endpoint na yan. Equivalence point na rin yan. Okay? So, yun yung idea sa titration. No? Okay? So, sayang lang na hindi natin ito magagawa kasi online tayo. Okay? So, actually, pag kunwari, inisip mo, ay, gusto ko bumili ng ganyan setup, sir. Okay lang, pero to be honest with you, ang Burette is 1.5. Okay? So 1.5 agad yung Burette. Paano pa kaya yung ibang equipment, di ba? So sayang. Hintayin nyo na lang mag face-to-face ulit. Malay nyo, magkaroon tayo ng opportunity to do that even after the semester. No? Hopefully. Okay? So that is how titration experiment is done. It is done in triplicates. Then we measure the volume of titrant required to neutralize the analyte. Okay? And then from that volume, stoic lang, then may sagot na tayo. Okay? So again. Okay, so in titration calculations, there are some required knowledge, no, para makapag-proceed dito. Okay, so ano yung mga required knowledge para maging easier yung approach natin dito? So ito yung mga pointers na sinabi ko. Na, una, kapag alam nyo that there is a acid and a conjugate base pair or base or conjugate acid pair, then you should know that you should use the Henderson-Hasselbalch equation because the presence of the acid and its conjugate base pair tells us na may buffer system tayo. So whenever we have buffer systems, we should use the Henderson-Hasselbalch equation. Number two, when we add acid, nababawasan yung base. When we add base, nababawasan yung acid. And that is totoo naman because of stoichiometry, di ba? When you add certain moles of acid, it reacts to the base, no? Okay, when you add certain moles of base, it reacts to the acid. So therefore, nababawasan yung moles ng isa't isa. Okay? Until maging complete yung reaction. Okay? So dito sa second pointer ko na to, this implies na kailangan alam natin yung stoic natin. Alam natin paano mag-compute ng moles and how to subtract them. Okay? Kasi useful yun mamaya. Okay? Next one, remember that, di ba sa titration, you have two liquids na pinag-a-add mo, dahan-dahan. What happens to the volume inside the Erlenmeyer flask? It increases, no? And what happens to the molarity when the volume increases? Nagdi-decrease yung molarity, di ba? So that's why we have to take note that yung ating molarity nagbabago upon the addition of titrant. So we have to use dilution formula. And then lastly, equilibrium, no? Importante itong equilibrium sa titration process. So sa una pa lang, no, parang siguro isipin niyo napaka-tedious naman nitong topic na 'to, ang daming gagawin, no? Pero mind you na madali lang 'to. Kasi alam niyo na kung paano mag-stoic. Okay? Last sem pa kayo nag-stoic, so kaya niyo 'yan. Yung Henderson-Hasselbalch equation na discuss natin last chapter. Okay? Yung dilution equation na discuss natin in chapter 1. And the equilibrium calculation, alam ko nagsawa kayo diyan nung midterm period, 'di ba? So that means you are very prepared, no, for titration calculations na. Okay? Kasi marunong na kayo mag-buffer, marunong na kayo mag-equilibrium, marunong na kayo mag-compute ng moles, and marunong na kayo dilute, 'di ba? Okay. So, overall, ito yung general formulas na gagamitin natin. For stoichiometry part, we will use this equation. Mole of titrant equal mole of analyte. Okay? This is the condition at the equivalence point. Okay, so yan yung condition at equivalence point. Bakit? 'Di ba? Sabi natin sa stoic last time, no, nung first sem, sabi natin at if the moles of acid and base are equal, then neutralized na yung ating reaction. So ganun pa rin dito, no. When the moles of titrant and the analyte is equal, then we are at equivalence point, no. Ibig sabihin they are equal na. Equal na yung mole ng acid, equal na yung mole ng base. Okay? So if we expand the mole, no? If we expand the mole, pwede natin yan ma-write as molarity times the volume, 'di ba? Remember molarity, that's moles divided by the volume. Rearranging the equation, we will get molarity times the volume equals mole. Okay? So that means the mole of the titrant can be calculated as the molarity of the titrant times the volume of titrant times SFT. Ano to? Stoichiometric factor. Okay? So kung ano yung coefficient niya sa stoichiometry, yun yung lalagay mo dyan. Okay, kunwari, 2 coefficient niya, lalagay mo 2. Kunwari, 1 yung coefficient niya, dilagay mo 1. Okay? Okay. So sa analyte, ganun din. So the moles of analyte can be calculated as the molarity of analyte times the volume of the analyte times its stoichiometric factor. Okay? So yan. So yan yung ating stoic calculation. So ito, alam niyo na to, chapter 1 to eh. For dilution calculation, we use the dilution formula M1V1 equals M2V2 or MFVF. No? Okay, it tells us that there is an equal number of moles before and after the reaction. The only difference is the volume and the molarity. Okay? So equal pa rin naman yung mole before and after the addition of liquids. Diba? Sa equilibrium calculation, marami tayong pinagdaanan, marami tayong pinagdusahan na equation. However, these are some of the important equation na gagamitin natin. You should know that Ka times Kb is 1 times 10 raised to negative 14 or equal yan sa Kw. San part to ng discussion natin? Sa acid-base phenomena. Okay? Okay, so yan. Ka times Kb equals 1 times 10 raised to negative 14 or Kw. And we also know, to compute for the concentration of acid, we can use the square root of Chaka. Okay? So instead of using quadratic equation, we can simplify that using small x approximation as the square root of Chaka. Okay? So alam nyo na yan. And if you apply it sa base, you will get this equation naman, CBKB. Okay? So magagamit natin to later on. And if you have buffer systems in the presence of base conjugate acid or acid conjugate base systems, you have to use this Henderson-Hasselbalch equation. pH equals pKa plus log conjugate base over acid. Or in the case of POH, that's pKb plus logarithm of the conjugate acid divided by the base. Okay? So, alam ko lahat kayo familiar na dito. Pero the question is, how are we going to apply all this knowledge sa titration? Okay? So, to apply them, let's proceed na sa main topic natin. So, monoprotic acid-base titration. So, from the word itself, sabi ko kanina, mono, isa, protic, that means nagre-react sa H. It means na ang acid and base natin, they react in 1-to-1 ratio. Okay? Kasi isang hydrogen lang yung pinagre-reactan nila. Si acid magbibigay ng isang hydrogen, si base magbibigay ng, si base tatanggap ng isang H. Kaya monoprotic. No? Okay, so again, kapag monoprotic acid-base titration, 1-to-1 yung ratio ng acid and base. No? Si acid magbibigay ng isang hydrogen, si base tatanggap ng hydrogen na yan. Okay? Assuming that we follow the Arrhenius definition or the Bronsted-Lowry definition. Okay? So, monoprotic acid-base titration can be classified into 3 subcategories. We have the strong acid, strong base titration, weak acid, strong base, and the weak base, strong acid titration. Okay? So, for each categories, there is a governing equation. No? May susundin tayong equation per category. Ito yung tricky with titration. Ibig sabihin na to, kailangan alamin mo muna yung condition mo before you apply the equations. Okay? If nakita nyo sa problem that you have a strong acid, strong base system, then you have to use stoichiometry calculations and dilution calculations. However, if you have weak acid or weak base, these two are governed by equilibrium naman. Okay? So, ngayon pa lang, sinasabi ko na sa inyo that marami nga tayong equation na may encounter. Okay? Kasi iba yung case for strong acid, strong base. Iba yung case for weak acid, weak base. Okay? So, magkakaibang sistema sila. So, that means, iba-iba equations na ma-encounter natin dito. Okay? However, for convenience, nilista ko na lahat ng equation na gagamitin nyo. Okay? So, sundan nyo na lang sila. Again, yung equations na ibibigay ko, this may be different with the others that you will find on YouTube. Kasi nga, sabi ko sa inyo, yung aking ibibigay ay yung simplified version na. Yung nasa YouTube kasi, for example, Khan Academy, yung mga binibigay nila equilibrium equations talaga. Ang akin ang bibigay ko yung approximated equations, na yung mga square root of Chaka. Okay? So, yun. So, let's start na. Okay? So, let's have the first one. Monoprotic strong acid, strong base titration. Okay? So, ano gagawin natin dito? For the titration of strong acid and strong base, kung sino mauna, siya yung analyte. Okay? So, that means yung strong acid, this is our analyte. And yung titrant natin ay yung strong base. Okay? Ibig sabihin, yung nasa Erlenmeyer flask ay yung strong acid. Ang nasa Buret ay yung strong base. For example, nasa Erlenmeyer si HCl. Tas ang nasa Burette ay si sodium hydroxide. Okay? So, ganun. Kung sino mauna sabihin, siya yung analyte. Strong acid, strong base. Analyte, titrant. Okay? So, when we have monoprotic SASB titration, it refers to the titration wherein your strong acids are the analytes. Example is HCl. And strong bases are your titrants. Example is sodium hydroxide. When we titrate SASB, okay, may apat na stages siyang dinadaanan. May initial stage, pre-equivalence point, equivalence point, and the post-equivalence point. Okay? So to understand bakit ganito yung equations natin dito, we have to know first what are the chemical species present in each stages. Okay? Alamin muna natin ano bang mga chemical species ang present at initial, pre-equivalence, equivalence, and post-equivalence. Kasi pag alam na natin yung species present per stage, malalaman na natin what equation needs to be used, di ba? Okay? So, initial tayo. Ano ganap sa initial? Wala ka pang nilalagay na titrant. Okay? So, ibig sabihin, ano laman ng Erlenmeyer flask? Ang laman ng Erlenmeyer flask ay tubig, pati yung acid lang. Kasi walang titrant eh. Okay? So that means to get the pH of the solution, that is the pH or the concentration of the acid itself. Okay? So again, kapag initial stage, ano yung nagko-contribute sa acidity? O ano yung nagko-contribute sa pH? Yung acid lang. Okay? That's why we can solve for the pH of the solution using the concentration of the acid alone. Okay? Kasi acid lang yung meron sa solution eh. Yung water, andyan talaga yan. Okay? So, yun yung initial stage. To solve for the pH, that is just the concentration of acid. I-negative log mo lang yon. May pH ka na. However, when I start adding titrant, ano nangyayari? Napupunta na ako sa pre-equivalence point. No? Kunwari, nagpatak-patak na ako ng titrant. No? What will happen to my acid? Yung acid ko, mababawasan. Kaya sabi ko dito, HA pero less. Ibig sabihin nun, yung acid nababawasan. Why? Because when we add bases to our acids, ano sabi ko kanina, when you add base to your acid, nababawasan yung acid. Okay? So, ganun yung ganap dito sa pre-equivalence point. When you add titrant, your acid will be lesser in quantity. And napoproduce yung salt. No? Okay? Ano yung salt? Yun yung acid plus base salt, di ba? Okay? So, yan. So, again, at pre-equivalence point, you are adding small amounts of titrant and nababawasan yung acid mo. So, since nababawasan yung acid mo, you have to compute for the mole of acid remaining. Okay? So, how do we compute for the mole of acid remaining? That is the mole of acid minus the moles of base added. Okay? O, kung ilan yung base na dinagdag mo, i-subtract mo yun dito sa mole ng acid mo. Nakuha mo na yung mole ng acid na remaining. Okay? Okay. So, in equation, that is MAVA minus MTVT. Bakit naging ganun, sir? Ganito kasi. Remember, ang ating analyte ay acid. Kaya, to solve for the moles of analyte, that is MAVA. Diba? Again, ang acid ay analyte. Kaya, MA times BA yung gagamitin natin. Moles ng analyte or moles ng acid yon. Yung titrant natin, ano yon? Yung base. Okay? So, to solve for the mole of titrant, that is MTVT. Okay? Mole titrant times volume titrant. Kaya ganito yung formula. Ito, mole ng acid minus mole ng base. This will give us the remaining mole of acid. Okay? So, once na nakuha mo na yung mole ng acid na natira, i-divide mo yun sa total volume. Okay? This part of the equation naman yung dilution. Yung pag-divide sa total volume. Dilution. Bakit? Kasi nagdadagdag na tayo ng liquid. So, So ano nangyayari? Nadidilute yung substances natin. So to account for the dilution, we have to divide it by the total volume. Ano yung total volume? Yung volume ng analyte mo plus the volume of the titrant added. Okay? So again, in summary, at pre-equivalence point, nababawasan yung HA natin, nababawasan acid natin. So to solve for the remaining acid concentration, that is mole acid minus mole base. Or in equation, MAVA minus MTVT. All divided by the total volume to account for the dilution. Okay? So yun yun. Then, ano mangyayari? Dagdag ka pa titrant, what will happen? Marireach mo na yung tinatawag kong equivalence point. No? At equivalence point, what happens is that lahat ng acid mo na-convert na into salt. Okay? So yung acid mo wala na. Salt na siya. Okay? So salt na siya. So of the two chemical species, which of them will contribute to the pH of the solution? Yung salt ba or yung water? Ang sagot ay yung water. Okay? Kasi we assume yung salt ions na lang yan floating around. Okay? So yung water, that is the major species that will contribute to the pH of the solution. And what is the pH of water? In neutral solution, 7. Bakit? Because of this. Square root of Kw. Okay? 'Di ba? Naalala nyo? Ano yung pH ng water at neutral solutions? 7. Okay? Ano sagot? Yung concentration H times concentration OH equals Kw. If the concentration of H is equal to concentration of OH, that means concentration of H is equal to the square root of Kw. Okay? Hopefully, naalala nyo pa yan, ha? And kapag kinuha mo yan, this will be 1 times 10 raised to negative 7. Kunin mo yung negative log 7. So that means at equivalence point, pH is equal to 7. Okay? So yan lang. Then, what if sumobra ka, nagdagdag ka pa ng titrant? Di post-equivalence na yan. Ibig sabihin, lagpas ka na. Okay? So at post-equivalence point, ano yung mga species present sa ating solution? We have the water, we have the salt, and we have the excess base. So of those three species, sino yung magko-contribute sa pH? Yung excess base. Okay? Yung excess base na yung magiging basis natin for the pH of the solution. So to compute for the excess base, we can calculate it as the mole base added minus the mole acid used divided by the volume total. Okay? So, baliktad na yung mangyayari. Sa pre-equivalence point, sobra yung acid. Kaya H plus nakuha natin. At post-equivalence point, sobra yung base. Okay? Sumobra na yung base. So, that's why to solve for the OH concentration, yung sobrang OH, that is mole base added minus mole of acid divided by V total. Okay? So ano yung mole ng base? That is MTVT eh. Kasi base yung titrant natin, di ba? What is the mole of acid? MAVA. Kasi yun yung analyte natin. Divided by the volume total. Okay? So ano mapapansin mo? Ano mapapansin natin dito? That as long as you know the chemical species present, you can have an idea how to compute for the pH of the solution. Okay? At initial, puro acid lang, kaya ang pH ng solution ay negative log ng concentration ng acid. At pre-equivalence point, nababawasan yung acid natin. So we have to subtract the amount of titrant added sa acid. Kaya ganito yung formula. Kasi nababawasan na yung acid eh. Nagdagdag tayo ng titrant. So gano'ng karami nabawas? E di yan. Subtract mo yan. Mole acid minus mole base divided by total volume. Makukuha mo yung H. Then negative log mo yan. Makukuha mo ng pH. Then at equivalence point, we assume that all acids have been reacted with base completely. So wala na tayong natirang acid. Salt na lang, pati tubig. So of the two species, sino yung magko-contribute sa pH ng solution? Yung water. And the pH of water is 7 when it is neutral. Diba? Ayan, kaya ganyan. And pag lumagpas ka, nagdagdag ka pa ng sobrang titrant, you will reach the post-equivalence point. May water ka and excess OH. So, sino na magko-contribute ng H? Sino na magko-contribute sa pH? Yung excess base. So, to calculate for the excess base, that is the mole of base minus mole acid divided by the total volume. Okay? So, let's apply that in, ito pala yung graph na. If you graph the pH with respect to the volume of titrant added, ito yon initial, then slowly, magi-increase yan kasi nagdadagdag ka ng titrant. So, nanuneutralize yung acid. And then, after the slow increase, bigla yung magkakaroon ng sudden change sa slope. The sudden change in the slope indicates that we reach the equivalence point. Okay? So, pag nakita nyo yung ganyang curve na yan, itong S curve na yan, itong sudden change sa slope, no? Pag nagganyan yung slope agad, ibig sabihin, equivalence point na yan. Okay? Andito yung equivalence point. And this is equal to 7 for strong acid, strong base titration. And then, lagpas ka onte, post-equivalence point ka na. Mas marami ng bases, kaya nasa taas siya ng curve. Okay? So again, pag nasa baba ng curve, acidic. Pag nasa taas, basic. Okay? So initial, you start here. You add titrant, unti-unti aakyat yan. And then suddenly, you will reach the equivalence point. There will be a sudden change in the slope of the curve. Biglang magiging ganyan yung curve. Then, dagdagan mo ng titrant, magiging ganun na ulit. No? So we call this part of the the inflection point. Kung favorite nyo yung algebra, geometry, or calculus, napakinggan nyo na to for sure. Inflection point is where mayroong sudden change sa sa slope ng curve natin. So kumbaga, andito yung first derivative ng curve, no? Kung masama loob niyo sa calculus, okay lang. Pero again, ito dito sa inflection point, ito yung equivalence point. Dito siya makikita. Okay. So yan. Diyan siya. Okay. So again, remember for every stages, there is a corresponding equation. Okay. So let's apply that. No. So let's apply that in this problem. Sabi dito, do the calculations needed to generate the hypothetical titration curve for the titration of 50 ml of 0.05 molar HCl with 0.1 molar NaO or sodium hydroxide. Again, ang sabi ko kanina, kung sino yung unang sinabi, siya yung analyte. Ito yung analyte natin. And that means yung sumunod ay yung titrant. Ano yung analyte mo? Strong acid kasi HCl. Ano yung titrant? Strong base. NaO yan eh. So, strong acid, strong base. Pag alam mo na strong acid, strong base yung condition mo, you use these equations. Okay? So, ganun gagawin nyo ha. Basahin muna problem. Alamin, sino yung analyte? Sino yung titrant? O, analyte ko, strong acid. Titrant ko, strong base. So, SASB yun. So, ano yung equation gagamitin ko? Ito. Yan. Okay? So, again, for every problem, iba-iba yung approach, no? Kaya be careful saan equation na gagamitin. Okay. So yan. So sabi dito, ito yung analyte natin, 50 ml of 0.05 molar HCl. Ito yung nasa Erlenmeyer flask, okay? Then yung nasa Burette, yung sodium hydroxide natin, yung 0.1 molar sodium hydroxide. Then, ang sabi dito sa problem, ano daw yung pH when I add 0 ml of the titrant, 10 ml of the titrant, 25 ml of the titrant, and 25.1 ml of the titrant. Ano daw yung pH ng solution pag inad ko ito sa analyte? Siguro sa ngayon, mapapaano kayo? No? Oo nga, paano ko sasagutan to? Okay. So, ganito. Whenever you encounter titration problem, first thing first is ito. Solve for the equivalence point. volume. Solve for the volume at equivalence point. Okay, ano uli gagawin nyo una? Pag nakakita kayo neto, bukod sa i-identify nyo analyte titrant, isolve nyo yung equivalence point volume. Required yon. Bakit? Kasi kapag di nyo alam yung equivalence point volume, hindi nyo alam kung nasa ang stage kayo. Initial ba to? Post-equivalence ba to? Pre-equivalence ba to? Hindi natin alam. Kaya ang gagawin nyo is alamin nyo kung ano yung equivalence point volume. How? Paano? Remember, sabi ko kanina at equivalence point, ano? At equivalence point, mole analyte equals mole titrant. Diba? We can express the mole analyte as MAVA equals MTVT. Ang hahanapin natin ay yung volume ng titrant at equivalence point or the VTEP. No? Solve mo yung VTEP. So that's MAVA divided by MT. Ano yung mole ng molarity ng analyte? Ano yung molarity niya? Sabi dito 0.05. Volume analyte 50 ml. ml gagamitin natin sa volume ha. Molarity ng titrant 0.1. So ano yung volume ng titrant at equivalence point? Solve nyo na lang. So that's 0.05 times 50 divided by 0.1, 25 ml. Okay? So ano gagawin ko dito? So since I know that the volume at equivalence point is 25 ml, that means ito yung equivalence point. Since ito yung equivalence point, ibig sabihin nito, ito yung initial, ito yung pre-equivalence point, ito yung post-equivalence point. Okay? Uli, ano nangyari? Sabi ko sa inyo kanina is ganito. Burahin ko muna uli para masundan. Hanapin nyo yung volume ng titrant at equivalence point. Kasi pag alam nyo na yung equivalence point, pwede mo na i-assign yung ibang stages. Di ba 4 yung stages? Basta alam mo yung equivalence point, pwede ka na mag-assign ng iba't ibang stages kada volume. Okay? Sabi sa calculation natin, Na equals NT or MAVA equals MV, MTVT at equivalence point. So we solve for the volume of titrant at equivalence point, we get 25 ml. Meaning, yung 25 ml na to, this is my equivalence point. So ibig sabihin nun, volume of titrant less than this is the pre-equivalence point. Ito, 10 ml less than 25 yan. No? Ibig sabihin, wala ka pa dito sa equivalence. Nasa pre-equivalence point ka pa lang. Ito, kapag wala kang dinagdag na titrant, edi obviously initial yan. Okay? Ito, 25.1. Lagpas ka sa equivalence point. Ibig sabihin, ito ay post-equivalence point. Okay? So, yun yung una mong gagawin sa titration. Identify kung ano ang volume ng titrant at equivalence point. Once na alam mo na yung volume ng titrant at equivalence point, mag-assign ka na ng stages. And then for each stages, there is a corresponding equation. Hopefully clear tayo doon. Pag may question kayo, don't hesitate to ask kasi medyo mahirap talaga tong topic na to. Okay? Kaya ina-emphasize ko pa ulit-ulit. Okay? So yan. So we now know the stages for each volume of titrant added. Ito, initial, pre-equivalence point, equivalence point, post-equivalence point. So, since alam ko na yan, I know my equations. Alam ko na yung equations na gagamitin ko. Alam ko na yung equations na gagamitin ko. Ito yon. So, yan. So, pag alam ko na yung equations ko, I can now solve for the pH. Okay? So, let's start. Initial. How do we solve for the pH of the solution at the initial stage? We say that the concentration of acid is equal to the concentration of your hydronium ion. Yun na yun. Okay? So kung ilan yung H mo, kung ano yung molarity ng HCl mo, yun na yung kanyang concentration. Okay? So, tas in-negative log mo na lang yun, you will get the pH. So pH is equal to negative log of 0.05. Now, compute natin. Okay, so the pH of the solution initially is 1.30. 2 decimal places madalas. Okay? So yan, 1 point na tayo. May score na tayo sa final exam, pati sa quiz. Okay? Kasi alam niyo na kung paano mag-compute ng initial pH. Di ba? So yun na yun. Again, for initial, pag strong acid, strong base titration, kung ano yung concentration ng acid mo, negative log mo lang yun. You will get the pH. How about pre-equivalence point? Ano sabi natin dito sa pre-equivalence point? Nababawasan yung acid kasi nagdadagdag tayo ng titrant. Okay? So, ilan acid na lang natira? Okay? So, ilang acid na lang ba natira? So, to solve for that, that's H plus equal mole acid minus mole base divided by volume total. Kasi nabawasan na yung acid natin eh. 'Di ba? Kasi nagdagdag na tayo ng 10 ml titrant. Okay. So to determine how much is left, we use this formula. Mole acid minus mole base divided by total volume. What is mole acid? Remember, acid is analyte. So that's MAVA minus mole base. Base is our titrant, MTVT, divided by the total volume. Okay? So we plug in MAVA, MT, and the VT. Okay. So that's 50 times 0.05 minus 0.1 times 10. Ano yung total volume? May 50 ml ka na analyte. Tapos, nagdagdag ka ng 10 ml na titrant. So, 60 ml yung total. Okay? So, ganun ha. Solve natin yan. 50 times 0.05 minus 0.1 times 10. Divided by 50 plus 10, we get 0.025 molar. Ito yung concentration ng H+. Okay? So, kunin mo yung pH niyan, negative log. The answer is 1.60. Okay? So, as you can see, upon the addition of small amount of titrant, nag-increase slightly yung pH. Okay? So, ganun. So, ano yung reason bakit itong formula ginamit natin? Ang sagot ay nabawasan po kasi yung acid. By how much? N acid minus N base. We express N acid as MAVA. We express base as MTVT. And you divide it by total volume to account for the dilution. Okay? And this is our pH. Hopefully clear ha. Pag may question kayo, don't hesitate to ask. Mahirap talaga tong topic na to. Kaya I encourage you to ask questions. Pag clear naman, tuloy-tuloy lang tayo. Okay? So let me rewrite the solution here. So that's 50 times 0.05 minus 0.1 times 10 divided by 50 plus 10. Yan yung formula na ginamit natin to get the pH. Okay. Next one, equivalence point. Anong species ang meron sa equivalence point kapag acid-base tayo? Strong acid, strong base. Ang species na nagko-contribute sa pH ay yung water na lang. Okay? Water na lang yung may dahilan kung bakit may pH reading dito. And we know at neutral pH, the concentration of H plus is square root of Kw. So this is equal to 1 times 10 raised to negative 7. I-negative log mo yan, the pH is 7. Okay, yan. Hindi pwedeng magkamali kayo dyan ha. Matik kapag strong acid, strong base, ang equivalence point ay 7. Matik yon. Okay? given that the Kw is 1 times 10 raised to negative 14 at 25 degrees Celsius yun. Okay. Lastly, we are now at the post-equivalence point. Nagpas na tayo sa equivalence point. What does that mean? Ibig sabihin, marami ng base kaysa sa acid. Ibig sabihin, the excess base will account for the pH of the solution. Okay? So, yung excess base na yung dahilan bakit may pH reading tayo. So, to solve for the excess base, that is the mole base minus mole acid divided by the total volume. Remember that your base is the titrant. So, let me replace this as MTVT. And remember that your acid is the analyte. So I will replace this as MAVA. So the formula is MTVT minus MAVA all over volume total. Yun yung dahilan bakit ganyan yung equation na ginamit natin. Kasi sobra na yung base, kaya ito yung formula. Base minus acid. Kanina, sa pre-equivalence point, sobra yung acid kaysa sa base. Kaya ganito. Sa post-equivalence point, sobra yung base kaysa sa acid. Kaya baliktad yung formula. Okay? And we are now solving for the OH. Okay? Plug in natin. Wala na akong space. Oops, lumabas yung sagot. Alam ko naman nakita nyo na yung sagot eh. Pero ina-explain ko pa rin bakit ganun, ha? Dito na lang, empty. Empty is 0.1 times volume of titrant 25.1 minus analyte 50 ml times 0.05 divided by the total volume. 50 na analyte, 25.1 na titrant. Okay? So that is equal to yes po, ano po meron sa prep, pre-equivalence? Ito yan ha. Ayan. Wala na kasi space eh. Ayan. Sir, type ko lang po, putol. And sa next slide, papakita ko yung cleaner version ng solution. Meron naman sa next slide then. Okay? So anyway, so for OH concentration that can be calculated as mole titrant, mole base minus mole acid divided by the total volume. The concentration of OH is 1.33 times 10 raised to negative 4. The POH is negative log of that, 3.86. And the pH is 14 minus that, which is 10.12. Okay. Ito pala. Sir, type ko lang po, naputol. Yung sa prep po at post, di po need ilagay negative. Hindi ko na siya sinulat dito. Kasi kulang na ako sa space eh. Pero kailangan, since pH yung nasa last column, alam nyo na kung paano kunin yung pH from H+. Kaya hindi ko na sinulat. Ang nilagay ko na lang dito is yung computation ng H+, pati ng OH. Then you should apply the necessary equation to get the pH. No? Hindi ko na siya papakita kasi alam niyo na 'yan. Okay? Kasi tsaka hindi na rin kasya kasi sa screen. Ayun. Okay. So yan ha. Again, you continue this ito ina-negative log nyo pa to get this. Niliitan ko na lang kasi to kasi hindi na kasya talaga. Hindi kasya eh. Okay? So yan. So again, you get the OH, mole base minus mole acid divided by the total volume. So ito yon. 25.1 times 0.1 minus 50 times 0.05. Again, check nyo ha, yung analyte hindi yan nagbabago. 50 ml pati 0.05 molar pa rin yan. Hindi yan magbabago. Ano yung nagbabago? yung titrant lang. Okay? Yung analyte, hindi. Okay? Baka isipin nyo, paulit-ulit ba talaga yan? Opo, paulit-ulit talaga siya. Kasi analyte siya. Okay, so mapapansin nyo yung titrant lang, yung volume ng titrant, yung nagbabago. Okay, so we get the OH concentration. This is equal to this, 1.33 times 10 raised to negative 4 molar. Solve for the POH, negative log niyan, 3.86. Ang kailangan ay pH. So 14 minus this is 10.12. So that's the pH of the solution when we add 25.1 ml of the titrant. Okay? So internalize nyo na kung ano mga ganap. Okay? Ito, share ko lang. Pakita ko sa inyo. Mainggit kayong mga taga FEU main. Lahat tayo mainggit. Wait lang ha, pakita ko. FEU NRMF academic break. Inggit sila. Ayan. So sila nag-academic break, tayo hindi. Nag-academic break na naman kayo sa akin last week. Kaya okay na siguro yan. Okay. Pero let's hope na maging lenient pa rin, no? Na yung admin. Kasi medyo malala talaga yung mga nangyayari recently. Imagine nyo yesterday, no, 12K cases daw. Grabe. Gano'ng karami yung 12K? Parang isang buong population na yun ng students sa FEU main pa lang. Okay. Okay, so let's pray na mapuksa na ang sakit-sakit at yung mga dahilan ng sakit natin. Okay. So anyway, so yan, going back, ayan yung equations. Okay, so this is the cleaner version. Okay. So if I draw the titration curve, okay, so ito, hindi ko to papagawin sa inyo sa exam, pero gagawin ko. Para sa assignment din, maging familiar kayo. How to draw titration curve. Titration curve is a curve in which your pH is on the vertical axis and the volume of titrant is in the horizontal axis. So ito pH 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Yan yung pH on the vertical axis, and on the horizontal axis, I have the volume of titrant here. Siguro gawin ko ang increments ko by 5, 10, 15, 20, 25, 30. Okay? So if I graph the pH with respect to the volume of titrant added, it will look like this. Okay, 1.3 siguro dito yan. 10 ml, 1.6, somewhere here. 25 ml, that's 7. Naduling na ako. Naduling na ako. Ayan. And 25.1, that is 10.12. Somewhere there. So if you connect the dots, ginagamit namin to kapag BS Chem kayo, no? Ganito yung mga lab experiments namin. Kina-curve namin yan. Okay, so magiging parang ganyan yung itsura ng curve. Okay. Medyo similar siya, pangit lang talaga ako mag-drawing. Pero yan, medyo similar to with the one that I showed you earlier. Yan, di ba? So slowly increasing, then suddenly you have your inflection point which has the equivalence point. Then magfa-flat na uli siya doon sa taas. So that is how we graph pH with respect to the volume of titrant. Okay, so any questions so far? Tanong nyo na yung mga kailangan itanong kasi ganito yung problem with titration. Pag hindi nyo siya nag-get sa una, wala na, mawawala na kayo sa dulo. As in. Kaya, if ever you have any questions, tanungin nyo na. Kasi yun naman yung goal ko. Sagutin yung tanong nyo. Okay, para maintindihan natin lahat. Okay. So, yan. And, share ko lang sa Facebook tong post ng FEU sana all lalagay ko. Sige. Anyway, So with that, let's proceed. Nasa PowerPoint na to nasa PDF na. If you have pag di nyo patapos, okay lang. Download nyo na lang PowerPoint. Let's have this exercise. Okay. So let's have this exercise. We have 10 ml of 0.1 molar HCl titrated with 0.05 molar sodium hydroxide. These are the volume of titrant added. Calculate the pH and let us graph the titration curve. Okay. Ano una kong gagawin? Kunwari, ako kayo. Tapos nakita ko to. Sabi ko, wala, ano to? Napahirapan na naman kami ni Sir. Di ba? So, ano una niyong gagawin? You identify first if that is a strong acid, strong base titration. Yung unang sinabi, ito yung analyte. Ito yung titrant, yung sumunod. Always ganun, ha? O kaya may keywords ka naman basahin nyo, titrated with. Ibig sabihin, ito yung pinantitrate. No? So, yan. Grammar lang din minsan. Okay? Kaya nga sabi sa mga FB post, reading comprehension talaga is the key. Okay? So, sabi niyan, titrated with this. Ibig sabihin, ito yung titrant. Okay? So, our analyte, identify mo kung anong klaseng acid, anong klaseng molecule yan. HCl, strong acid yan. NaOH, strong base yan. Alam natin yon. So, this is a SASB titration. Strong acid, strong base titration. So, that means we have to employ this formula. Formulas. No, ayan, itong mga formula yung gagamitin natin. Okay? So, yan. So, alam na natin yung ating condition. We know the formula to be used. No? Huwag nyo kabisaduhin. Pero kung kabisado, better. Pero okay lang, ilista nyo yung, o kaya i-print nyo na lang yung PowerPoint natin. Again, simplified version yung PowerPoint ko kaysa sa mga nasa libro. Okay? Kaya, ayun. Baka magtaka kayo, wala sir, ba't ganito sa libro? Simplified nga kasi sa yung akin. Okay? So, yan. Pinadali ko na yung buhay natin. Okay? So, yan. So, yan. Ano susunod? Alam ko, SASB to. What's next? Identify the volume at equivalence point. The volume of titrant needed to reach equivalence point. Yun yung susunod mong gagawin. Okay? Find volume at equivalence point. Hanapin mo si VTEP. No? Si VTEP. Okay, so paano kinukuha si VTEP? So we know at equivalence point, molarity of mole of analyte is equal to mole of titrant. Expressing that into molarity and volume, we get MA/VA equals MT/VT. Okay? So we solve for the VT is equal to MA/VA divided by MT. Plug in. So we have 10 times 0.1 divided by 0.05. So we find VTEP equal to, wag nyo i-mental. So ano si VTEP? Equal siya sa 20 ml. So we just found out that the volume of titrant at equivalence point is 20 ml. So once alam mo na ang equivalence point, then you can now assign the stages. Okay? So ganun. Again, makikita nyo yung progress natin. Alamin mo kung ano yung analyte, ano yung titrant, SASB ba yan. So kapag alam mo na yun, alam mo na yung equations per stage. Next, alamin mo kung ano yung equivalence point volume. Hanapin mo si VTEP using this equation. Ito lang naman yung equation na yun Okay? So once alam ko na si VTEP o 20 ml yun, then I can now assign the stages. No? Alam ko na kung anong stage yan. Okay? Mag-assign na tayo. Binura ko na ha. Okay. So, pag 0 ml, malamang yan yung initial. Okay. O 1 ml, o less than 20 yan So, ito yung pre-equivalence point. Ito rin, pre-equivalence point. Ito rin, pre-equivalence point yan. At 20 na. Pag 20 na, equivalence point na. O paano to lumagpas ng 0.1 sa equivalence point? Post-equivalence point na yan. Okay? So, assigning the stages is very crucial. Crucial to. Kasi pag hindi mo alam kung asang stage ka, wala kang sagot. Okay? So, yun. Kaya kailangan alam nyo kung nasa na kayo. Okay. So, how do you assign the stages? Alamin mo si VTEP. What is the volume of titrant to reach equivalence point? So, ito. May sagot na tayo sa pH dito. What is the pH at equivalence point for strong acid, strong base? That's automatically 7. Because we know H plus equals square root of KW lang. May 1 point na tayo. How about the others? Okay. So ito, unahan ko na kayo magsagot ha. But I will leave this to you to practice. No? Pwede kayo magsagot ngayon pero mas mauuna ako matapos kaysa sa inyo. Kasi kanina ko pa ito sinasolve. Okay. Kanina pang umaga. So bibigay ko na yung mga answers sa pH. You already know how to solve for the pH, no? Or the H plus, the OH. Pakita ko na lang yung equations dito. Plug in mo na lang lahat ng info. You will get the pH. Then I will draw the curve. Okay? So for initial, H plus is equals to the concentration of acid. Okay? Negative log of 0.1 is 1. Okay? So for pre-equivalence point, the equation to be used is H plus equals MAVA minus MTVT divided by V total. Okay, you plug in the volume of titrant to this equation, you get the negative log, you have the pH. So let me solve for that, ha? Uunahan ko na kayo, paunahan tayo. Pero again, sagutan nyo pa rin to at on your own na. Sagutan nyo pa rin on your own. Baka kasi mamaya nakatingin lang talaga kayo, no? Mahirap yon pag nagku-quiz na tayo. Okay, so this is 1.06. Volume equals 10. Plug in ko naman yung 10. That's 1.60. Okay. Plug in ko 19.9. This is 3.78. Ayun, tapos na ako. Kalahati na agad. Okay. So as long as na-assign nyo na sa calculator nyo yung correct equation, change na lang kayo ng volume. Ganun na lang. Post-equivalence na ako, ha? Unahan ko na kayo. What's the equation for post-equivalence? Ang makukuha mo ay OH. Ang kailangan mo pH. So you have to convert OH to POH. Then from POH going pH. Okay? So alam nyo na yan. Okay? Hindi pwedeng hindi nyo na alam yan. Kailangan alam nyo pa rin yan, ha? So to convert POH to pH, that's 14 minus POH. Okay? So the equation to be used is this. MTVT minus MAVA over V total. Bakit ganyan? Kasi sabi ko nga, sobra na yung titrant. Kaya titrant yun nasa harap. Sobra na yung titrant, kaya nga lumagpas na tayo. Okay. So yan. So plug in the values. Paunahan tayo. Minus log. 20.1 plus 10. So this is 10.22. Okay, palitan ko yung volume, 25. This is 11.85. And then 30. .10. Okay, so these are the pH values at different volumes of titrant. So allow me to draw the curve, no, para makapag-solve pa kayo. Magko-curve lang ako. Let me draw this. So pH on the vertical axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And on the horizontal axis, I have my volume of titrant. Oh, sorry. Wait lang. Okay. Volume of titrant. Okay. So 5, 10, 15, 20, 25, 30. Habang nag-graph ako, mag-solve kayo ha pag di pa kayo tapos. Pa-plot ko lang to. ml 1.60. $25. Ay, 20 pala yung ano. 7. $20.1 is 10.22. Okay, then 11.85. O, lumagpas na doon. Siguro dito na lang. Then 12.10. Okay, so I have my points in the graph. Let me connect them. O, diba? Mas maganda yung curve natin ngayon kasi mas marami tayong data points. Okay? So as you can see, it resembles the graph I showed you earlier. No? Okay. So this is the common titration curve for strong acid, strong base. No? Ano yung mga features niya? You have a small, you have an incremental change in the pH when you add titrant. Then upon reaching the endpoint, you will have an inflection point. No? Ito yung endpoint, andun siya sa inflection point. Again, what is an inflection point? That is a curve, that is a part of the curve where the slope is changed drastically. Laki ng pagbabago sa, malaki yung pagbabago sa slope. Then, eventually, magpa-flat out uli yan. Parang ganito lang din. Okay? So, that's the titration curve. If kayo, mahilig kayo sa math, no? Which is ginagawa naming mga BS Chem, we do the first derivative of this. Ang itsura niyan ay ganito. Okay? So, the first derivative, dy dx, this is the volume at the end point. Ganun ginagawa namin. That's how we apply calculus sa Anachem. Okay. Pero siyempre, hindi natin gagawin yan kasi hindi naman kayo BS Chem. Basics lang tayo. Okay. So, yan. If you get the second derivative, no, makukuha mo rin yung endpoint. No? Medyo amazing yung calculus. No? Okay. So, yun lang. Share ko lang. Okay. So, that's how we solve for SASB titration. Okay. Diba? Ang tagal natin nagdi-discuss. Halos 2 hours na tayo dito. No? Okay. Makulit yung pusa ko. Wait lang. Nanggugulo siya. Okay. So, let's proceed with the next one. Okay. So, I think wala naman kayong question. Pag may question, sabihin lang. So, let's proceed with the next one. We have the strong base, strong acid titration. Ano yung kanina? Strong acid, strong base. Ngayon, baliktad. We have the strong base as your analyte and the strong acid as your titrant. Okay? So, strong base ang analyte, strong acid ang titrant. Baliktad. Okay? So, ibig sabihin nun, yung ating equations, baliktad din. Okay? So, magbabaliktad tayo ng equations. Kasi kanina, strong acid, strong base, di ba? Ngayon, strong base, strong acid. Palit sila ng rule. Okay? But the concept is still the same. Okay? So, for initial state, you have your, ang gugulo na yung pusa. So, at initial stage, you only have your base, no? So, the base will contribute to the pH, no? So, we solve for the pH as, ito. Ayan, so we solve for the pH as, pOH muna. Kunin mo yung pOH from the concentration. Then, saka mo siya isubtract sa 14. You get your pH. Then, at pre-equivalence point, nababawasan yung base kasi you are adding acid. Okay? So, nababawasan ng base kasi nagdadagdag ng acid. So, to solve for how much base is left, we use the formula mole base minus mole acid divided by the total volume. Similar sa pinagagawa natin kanina. Okay. However, this time, the base is the analyte. The titrant is the acid. The acid is the titrant. Okay. So, nagkabaliktad lang kasi this time, mas marami na yung base kaysa sa acid sa pre-equivalence. Kaya, yan. Okay, so again, take note. Yung base ay yung analyte na natin. Yung titrant ay yung acid na. Kasi nagkabaliktad tayo dito eh. Okay. Then, after nun, after adding enough amount of titrant, we will reach the equivalence point. Okay, the one that contributes to the pH of the solution is the water. So that's negative that's square root of Kw, or if you solve for pH, that's equal to 7. Ganun pa rin, 7, kasi strong acid, strong base yan, remember. And then we have the post-equivalence point kung saan sumobra na yung titrant, yung acid na yung sumobra. So to solve for the excess acid, that is the mole acid minus the mole base divided by the total volume. Similar to what we did last time. Kanina lang. Ano yung sobra kanina? Yung base sobra. Ngayon, yung acid naman yung sobra. Okay. So the resemblance is there now. But take note lang na baliktad yung roles nila. In our case today, the bases are analytes, the titrants are acids. Kanina, baliktad. Yung acid yung analyte, yung base yung titrant. Okay? So, be careful. Okay, so yan. We have all those equations. Similar pa rin yan sa kanina. So, we can now proceed. Okay, so if you graph the curve, no, the titration curve, it looks like this. Parang binaliktad siya na, binaliktad siya sa kanina. Okay, baliktad siya. Diba, kanina we started from here, we started sa baba, and we ended up sa taas. Ngayon, we started sa taas, and we will end up sa baba. Okay, kasi base meron tayo eh. So, kailangan mataas pH. Then, upon the addition of acid titrant, dahan-dahan niya magbaba, and then we will reach the inflection point wherein we can find the equivalence point. And then, pag nasobrahan tayo ng titrant, nasa acidic part na tayo. Okay. So again, remember that for each stages, there is a corresponding equation to be followed. Ito yun. Okay? So yun. Okay, so let's try this one. Calculate the pH during the titration of 50 ml of 0.05 molar sodium hydroxide with 0.1 molar HCl at 25 degrees Celsius after the addition of the following volumes of the reagent. Ito yung volume, hanapin yung stage, hanapin yung corresponding pH equations, and i-graph natin. Okay? Ano una yung gagawin? Identify the analyte and the titrant. Ako na rin, hindi mo to alam. Ako na rin, wala yan. Ako na rin, nasa quiz tayo. Siyempre, di ko sasabihin kung ano yan. Okay? Kasi pag sinabi ko yun, madali na yung buhay eh. Pero siyempre, alam nyo naman, nag-enjoy ako sa mga solving, kaya yan. Alamin muna natin. Sabi sa problem, ito yung unang binanggit, no? Sodium hydroxide, strong base yan. And then we have HCl as our titrant, strong acid. So we have strong base, strong acid. Ganon gagawin nyo ha. Alamin nyo kung anong equation ang gagamitin. By identifying what type of acids or base you have. Yun yung una nyong gagawin. Yung unang sinabi, yun yung analyte madalas. Then yung titrant, yun yung iba-iba yung volume. Of course. Diba? Gulat kayong analyte yun, nagbabago yung volume eh, no? Baliktad ka dun, kapatid, no? So, kailangan yung titrant yung nagbabago yung volume. Okay. So, now we know that this is an SBSA titration. SBSA titration to. So, alam na natin yung corresponding equation per stages. Ito yon. Ayan. So, let's solve for the pH. Masasolve ba natin agad? No. Bakit no? Kasi we have to look first for the equivalence point volume. Hanapin mo si VTEP. VTEP. yan yung una mong gagawin. So we say Na, Nt. Okay? So MAVA equals MTVT. We solve for the VTEP. That is MAVA divided by MT. Okay? And then plug in whatever is given. So you have 50 ml of the base, analyte, 0.05, divided by the molarity of titrant, 0.1. Solve natin. 50.05 divided by 0.1. Okay, so that's 25 ml. So si VTEP natin ay 25 ml. So this is our equivalence point. So since we know the equivalence point already, we can now assign different stages now to other volumes. 24.5 is the pre-equivalence point. 25.5 is the post-equivalence point. Okay? Ganun ha. Alamin si VTEP. Kasi pag alam nyo na si VTEP, volume of titrant at equivalence point, pag alam nyo na siya, you can now assign stages to different volumes. And since alam mo na yung stages, there is a corresponding equation for that. Okay? So, let's solve. Ano sabi natin? At pre-equivalence point, pag strong base, strong acid, nabawasan na yung base natin. So, the corresponding equation to be used is this one. Mole base minus the mole acid divided by the volume total. Okay? Kasi nabawasan na yung base natin eh. Kaya yan yung equation na gagamitin mo. What is mole base? Now, mole base is MAVA. Base yung analyte natin, di ba? Kaya MAVA siya. What is mole acid? O, yun yung titrant natin. So, yun yung MTVT. Okay? Divided by the volume total. Okay, so since you now know kung sino, kung which is which, no? Hindi ko alam Tagalog nun eh. So, since you now know which is which, no? Pwede na tayo mag-plug in. Okay? Plug in na natin yung MAVA pati MTVT and the V total. Pag may question, sabihin ha. Para ma-clarify natin agad. Kasi pansin nyo, ang daming sinusolve, no? Slide 17 pa lang tayo out of 52 slides. Yeah, GG tayo. Okay, so volume ng titrant is 24.5. So that's 50 plus 24.5. Okay? Again, ipag-add mo yung volume ng analyte and the titrant to get the volume total. Be careful ha. Baka mamaya mapagpalit nyo yung volume eh. MAVA, MTVT. Okay? So mag-ingat ha. Baka mapagbaliktad yung volumes and polarity. So we solve for the OH, then we solve for the pH. No? OH, okay, so ganito yung flow ha. OH, gawin mong POH, then gawin mong pH. Hindi ko napapakita kasi alam nyo na yan. Okay, so pindutin nyo lang natin sa calcu. And hopefully tama yung lumabas sa atin. pH is, ang bilis na, 10.83. Ayan ba nakuha nyo? Hopefully yan din ha. Kasi yan yung sagot eh. Pag di yan yung nakuha nyo, there's something wrong with the equation. Ayan, so that's the pH. At when we add 24.5 ml of the titrant, at equivalence point, what is the pH? Ito, hindi kayo pwede magkamali. 7 yan. At 25 degrees Celsius. Because remember, H plus is equal to the square root of KW. So, saan to equal? 1 times 10 raised to negative 7. Negative log mo yun. You will get 7. Okay. Pag sinagot mo dyan, iba, mali agad yun. Sayang. Malay nyo, puro ganito sa quiz, no? Puro equivalence point pala lahat, no? Pero syempre, hindi tayo ganun. Alam nyo naman, lahat ng trickiness, kaya natin gawin. Kaya yan. Basta dito, wag magkakamali, ha? Ayan. How about this one? Post-equivalence point. Ano sobra sa atin pag post-equivalence? Acid na. Okay, so sobra tayo ng acid. We can compute for the excess acid as mole acid minus mole base divided by the volume total. Okay? So, saan equal yung mole acid? Remember, acid is the titrant. So, that's MT VT. Mole base is the analyte. So, that's MA VA. Okay? Hopefully, napagdudugtong-dugtong nyo yung mga shortcuts natin. So, since we now know the equation, plug in the values. Okay? Let me plug in the values. Titrant muna kasi siya yung sobra. Times 25.5 minus analyte 50 times 0.05 divided by 50 plus 25.5. Okay, so the pH is 3.18. Okay. So if you graph that, pangit tong graph natin kasi 3 points lang. Medyo ganito itsura niyan. Okay. So you will have an inflection point in the 7, pH equals 7. Okay, so yan. Okay, so yan. So if you have any questions, let me know. Or so far clear naman tayo, no? Pag hindi, sabihin nyo lang, ha? Again, ina-encourage ko kayo to ask questions kasi pag hindi natin nasundan ang first easy topics, mahihirapan na tayo sa susunod na topics. Okay? So, kailangan ngayon pa lang nasusundan na. Okay? So, this is the answer. Okay? So, yan. Hopefully, I made myself clear. Ha? Okay. So, for your activity na lang to at home. So, I will answer this next meeting. Bibigay ko na yung sagot mismo. So, I want you to do this. No? So, this is a base strong acid titration. You have sodium hydroxide as your analyte and HCl as your titrant. Okay. And this is the corresponding volume of titrant added. I want you to identify the stages, the way to solve the pH for each stages, and the corresponding pH for that stage. Then after that, you plug it into this graph, no? Gawa kayo ng titration curve. So gusto kong ma-practice nyo rin to. Okay, so please do this activity na lang. Okay? So similar yan dito sa ginawa ko kanina. Okay. Ayan, 'di ba? Ganda ng curve natin, no? Kitang-kita mo talaga yung slowly increasing, then suddenly inflection point, then plateau. Okay, so sana ganito din magawa ninyo. So I want you to answer this as your activity. Okay? To para masanay kayo. Okay? So yan. Okay, so with that, I will end the session early, ha? Hindi ko na habulin yung ibang topics kasi I don't want you to be sabaw. No? Kasi kapag sabaw tayo, wala nang learning doon. So, yan. So, hindi ko sinasagad yung classes, di ba? Papansin nyo, pag 2 hours, okay na tayo madalas kasi I know nalulutang din tayo. Kaya ako rin naman minsan. Kaya, okay. So, pahinga muna. No? Pero I want you to, for the vacant time, so you still have around 1 hour, no? So, sagutan nyo to after the class. And then, I will give you an idea on the succeeding topics na. Okay? So, ito. So, tapos na tayo sa ating discussion, pero magbibigay ako ng insights kung ano i-discuss ko next meeting, ha? Okay. So, next meeting, we will discuss this. Okay? So, tapos na tayo sa strong acid, strong base. Papansin nyo, dalawa siya, no? We have the SASB, and then we have the SBSA. Okay? So alam natin there are 4 stages for each. Okay? And the equation is ano naman, understandable naman siya. Kung sino yung sobra, yun yung siya yung basis for the pH, di ba? Kunwari, sobra ng acid, edi H plus makukuha mo. Mole acid minus mole base divided by total volume. Kunwari, sobra ng base, ano gagawin mo? Edi mole base minus mole acid divided by total volume, di ba? Ganun lang naman for the strong acid, strong base. So this is the very easy problem sa titration, sa monoprotic titration. The problem is kapag weak acid. Kasi sabi natin, these two are governed by equilibrium. Okay? So, equilibrium na dyan. How? Okay? So, let me show you. So, discuss pa natin to next meeting pero I want you to be familiar na. Okay. So, if we have a weak acid titrated with a strong base, that means the weak acid is your analyte and the strong base is your titrant. Okay. So remember, sa ating equilibrium, we can solve for the initial concentration of the acid using the square root of Chaka. Diba? Kung sa kung sa YouTube kayo manonood, ang ipapakita nila sa inyo ay yung full equilibrium equation. However, alam ko medyo may trauma na kayo sa equilibrium kaya shortcut ko na. Okay? So yan. So ginanyan ko na. Okay. Kasi baka mamaya kita nyo, equilibrium na naman, ayoko na. No, kaya mo yan. Square root of Chaka lang yun Okay, so ganun. So again, when you don't have any titrants added, the pH of the solution is the square root of Chaka for the weak acid. Diba? Alam nyo na yan, dati pa yan However, what happens when I add the base? When I add the base, some of the acid are converted into its conjugate base form. Diba? What happens when we have an acid and a conjugate base? We have a buffer solution. Okay? So ito yung unique when it comes to weak acid or weak base titration. When you add base to your acid, to your weak acid, there exists an equilibrium between a conjugate base and the strong and the weak acid. Okay? So may equilibrium sila. Therefore, may buffer tayo. So the equation to be used here is the buffer equation or the Henderson-Hasselbalch equation. Diba? So iba siya compared sa kanina. Okay? Diba kanina, mole acid minus mole base divided by total volume. Ngayon hindi. Okay? Henderson-Hasselbalch equation na siya. Bakit naging ganyan equation, sir? Kasi we have an acid and the conjugate base. Basta magka-partner yung dalawa sa solution, buffer solution yon. Okay? So, yan. Kaya Henderson-Hasselbalch ginamit dyan. Baka kasi magtaka kayo, ano ba yan? Ba't naging ganyan na? Buffer lang yan. Okay? Next one. Pagdating ng equivalence point, ang natitira na lang natin ay yung conjugate base. Okay? And yung conjugate base natin, when it reacts with water, it produces OH. Okay? Okay, so ito yung equation na yun. When our conjugate base reacts with water, it produces the base. No? So ibig sabihin, siya yung source ng base. No? Siya yung nagko-contribute sa pH ng solution natin. Okay? So the equation to be used there is the square root of CBKB, okay, to get the concentration of the base. The concentration of the base can be calculated using this equation. This is the dilution formula lang. So dilution formula lang yan. Okay. Then after that, kapag nagdagdag pa tayo ng sobrang titrant, ang present sa solution natin ay water, conjugate base, and the base, which is stronger kasi strong base yan So yung excess base na stronger, ito yung magiging, ito yung magko-contribute to the post-equivalence pH values. So mau-overpower neto, ba't ayaw gumana? Mau-overpower neto, ito. So ito yung basis natin for the pH. That's why we use this equation. Okay, so yun. So, bakit gusto ko, aralin nyo na siya in advance? Kasi, familiar na kayo with the buffers. So, basically, apply mo na lang yung equations. No? So, ganun pa rin you identify the VTEP. No? Hanapin mo si VTEP. Kunwari, 50 ml yung VTEP. Edi yun. Ito yung equivalence. And ito yung pre, initial, then post. Then, apply the equations listed here. Ito na yung sagot. Yan. Siya nga yung equivalence point. Nilagay ko na yung sagot. So, pwede na kayo mag-practice. Pero, i-discuss ko ulit yan next meeting, ha? Para mas ma-clarify yung mga questions sa ating puso. Okay? Then, may itatry din kayong activity. Okay? Then, kapag weak-based naman, so ito, insight na lang to ha? Kapag weak-based naman, titrated with strong acid, ano meron tayo? May base tayo initially. How do we solve for the pH or the concentration of OH of the base? That's the square root of CBKB. Kabaliktaran yan ng square root of Chaka. Okay. So, CBKB kapag base. Then, what will happen when you add the acid titrant? Magkakaroon ka ng base and the conjugate acid. If you have a base and a conjugate acid, you have a buffer system. That's why we use the buffer equation here. Ayan, buffer equation. And then, eventually, kapag nag-add ka ng enough titrant, wala na tayong base. Ang matitira ay acid. Conjugate acid rather. And ang ating conjugate acid, when it reacts to water, it produces H+. It produces hydronium ion. So the pH of the solution can be calculated from the dissociation of the conjugate acid. So ito na yon. Parang Chaka din to, no? Square root of Chaka. However, base yung gamit natin. Okay? And ito yung equation to solve for the concentration of the conjugate acid. Dilution formula lang yan. Okay? And then lastly, pag nagdagdag tayo ng sobrang pag nagdagdag tayo ng sobrang titrant, ma-overpower ng acid yung conjugate acid. So that means the pH of the solution will be heavily reliant on the excess titrant. So we solve for the moles of the titrant that is in excess. Okay, kaya naging ganito yung formula. So ito yung titration curve niyan. So initial, the square root of CBKB. Then you have a buffer region wherein the pH doesn't change that much. And then suddenly inflection point wherein you will have your equivalence point. And then after that, you will have the post-equivalence point. Naglagay din ako dyan ng similar problem. You can try to apply this question, these equations, and then may corresponding answer na doon. Di-discuss ko pa to next meeting naman. Okay, pero on a faster pace na. Then sasagutan natin to next meeting. Although pwede nyo na rin to sagutan in advance, ha? Kasi you have 1 hour pa naman. And then acid-based titration indicators, ito yung mga colors. So, saka na yan. Okay, so basta yun lang yung gusto ko muna ibigay sa inyong assignment. No? So what I want you to do is to draw the titration curve for this, for the strong base, strong acid titration. Asan yun? Ito yun. So I want you to draw the titration curve for this one. Ay, hindi naka full screen. Basta yan. Okay, the titration curve para masanay and practice the advanced topics. No? Kasi binigay ko na naman yung solution. I want you to, to be more familiar para pag nag-solve tayo, easier na lang on a much faster pace tayo next meeting. Okay? So with that, do you have any questions about our session today or clear naman tayo? Okay, so let me know if may question. Kasi again, as I told you earlier, pag may question, itanong. Kasi pag hindi na gets agad, hindi nyo na mag-gets yung susunod. Okay, so ganun kasi yung titration. The baby steps are very important dito. Na yung mga unang diniscuss natin, napaka-important yan. Kasi later on, may papakita ako sa inyo para malula kayo. Okay. Ayan. Later on, ganito na yung mga ganap natin. Although di ko kayo bibigyan nito. Yan, sandamukal na equations na. Yan, bulaga. Ang daming equivalence point. O, tignan nyo. 1, 2, 3. Triprotic acid yan. Okay, and then for each step, there is a corresponding equation. Bulaga, ang dami. Ayan. Ito, this is diprotic base. Ayan. And these are the corresponding equation. Pero hindi ko na kayo bibigyan ng malalang problem. Basic lang. Okay. So, sir, kailan po ang schedule ng quiz? I am expecting that by, kasi today, ang kaya natin na cover ay ito. Akala ko nga aabot tayo sa weak acid, weak base, pero ayoko na habulin kasi baka masabaw tayo. So, hanggang dito lang yun ang cover natin today. So, I'm expecting by Friday, we discuss up to this part. Weak acid, weak base, indicators, and polyprotics. Okay, although sa polyprotic, wala tayong solving dyan. Okay, wala tayong solving dito. Ayoko magdusa kaya. Okay, so dito lang tayo maghihirap. Itong polyprotic, skip ko na yan. Although bibigay ko yung reason ba't ganun yung formulas. And then lastly, titration of acid-base mixture. I think we can discuss this by Monday. So, Monday next week yan. So, I'm thinking na ang inyong exam will be scheduled around April 22. Okay. However, we will have synchronous classes by that time. Sorry ha, pero ayun. We have to do synchronous classes na tuloy-tuloy na yung sync classes natin. Especially ako, binabagalan ko yung lesson kasi mahirap yung topic eh. Okay, so ina-adjust ko yung space ng discussion sa hirap ng lesson. So yung next two topics kasi mahihirap talaga yon. Etong titration and yung electrochem. Yung electrochemistry, mahihirap yon. Kaya binabagalan ko. Okay. Kaya ganun. So 3 meetings tayo for titration. Then April 22 to April 29, electrochem tayo. So magku-quiz kayo. Pero may session pa rin tayo that day ha. So pasensya na ha. Although medyo bibigyan ko kayo ng perks doon. Bakit? Siguro gagawin kong multiple attempts yung quiz, no. Multiple attempts ko na yung quiz para makabawi yung mga kailangan bumawi. Okay. So yun na lang yung pang-compensate ko kasi hindi ko kayo mabibigyan ng vacant day to answer the quiz eh. Okay. So, ganun na lang. Multiple attempt na lang. Siguro dalawang attempts. Okay. So, yun. Quiz for this topic is April 22. And then we will discuss electrochem on that day. And the quiz for electrochemistry is April 29. And then, yung last two topics, madali na lang yun. As in, super dali na lang yun. Yung chromatography and the spectrophotometry. Dadalian ko na yan. Okay? Papamigay ko yun. So, focus lang tayo dito sa hardcore topics. Okay? So, yun. So, thank you for that. Any other concerns? By the way, mag-iingat kayo parati ha. Especially sa ating classmate na si John Zyrene. So, mag-iingat ha. So, always pray for the health of the others, especially that the COVID cases are surging. No? So, for the past few days, hindi na siya nababa sa 10K because of the Philippine variant of the virus. Masyado na siyang infectious. So, for those na naman, na hindi naman exposed sa wag na muna lumabas. However, for those who are yung kailangan talaga lumabas ng bahay to help the family, kung chores man yan or work, no, mag-ingat kayo lalo, no. So yun, meron nga akong mga students, no, sa PUP naman, may student ako na nag-work sa clinic. Mas scary, sabi ko, naku po, mag-ingat ka dyan, na kasi delikado talaga, no. So yun, kung in case na may affected sa inyo ng virus, please send me send nyo sa akin pati sa program head natin yung medical results ng family member nyo and kayo, no? If ever, wag naman sana maging COVID positive, no? I-send nyo sa amin yung mga ganong documents so that we can ask for the university health office to assist you. Okay? So, yun. So, tulungan na lang tayo. And ako, ang magagawa ko sa inyo is to be lenient na lang. Okay. So, leniency in the form na multiple attempts na yung gagawin kong quiz, no? Para more chances of winning. Okay. And then, ayan. So, babagalan ko yung turo for very hard topics and then I will provide you, no? Katulad pa rin ng midterm period, I will provide you more samplex, no? More prob sets, no? Para ma-practice, no? With solution. Okay? So, that's the best I can do for now, other than to assist you sa yung pag-elevate ng case nyo sa UHS, no? Basta yan lang, ha. So mag-iingat kayo parati. I will see you by next time. Hopefully nasa FEU main na tayo noon, no? So, sana makita ko kayo in person, okay? Na ligtas and walang sakit, okay? So I'll see you again next time. So that will be all for our session today. So ingat parati, no? Uminom ng gamot, vitamins, mag-alcohol. Huwag kalimutan alcohol. So ingat, bye-bye. And enjoy the rest of your day. Okay, so ingat. I'll see you again on Thursday. Bye-bye.